A simple simulation of galactic colonization suggests something almost uncomfortable, even at interstellar speeds that are barely more than what our best probes touch today. Around 17 kilometers per second, a patient civilization could hop from star to star, founding settlements, pausing to build, and then moving on. Give them roughly 300,000 years for each leap between neighboring suns. Tack on another 100,000 to seed and stabilize a new colony before launching the next wave, and watch the frontier creep outward. Sector by sector, this slow tide would not stay slow forever. On cosmic timescales it races. By the end of less than a billion years, a mere slice of our galaxy's 13+ billion year history, almost the entire Milky Way, could be mapped with boot prints and beacons. Now put that beside the other number that refuses to leave the room: worlds. Rocky planets, temperate or at least temperable, are not a cosmic accident. They're common. Many formed long before Earth, hundreds of millions, even a couple of billion years earlier. If life likes to spread, if life is life the way we know it, then somewhere, someone should have had a head start. Which is exactly why the question never stops echoing. If intelligent life is out there, why haven't we found it? Why isn't the sky littered with the unmistakable signatures of minds older and greater than ours? That is the spirit of Fermi's paradox. Put plainly, the universe had time. If advanced civilizations arise even rarely, and if they have any taste for expansion or signaling, we should have tripped over their footprints by now. But our telescopes return silence. Our antennas, static. Where is everybody? Optimists sketch the possibilities in the language of energy. Kardashev gave us a ruler. Type 1 civilizations master the power budget of their planet. Type 2 harness the output of their star. Type 3, in principle, the luminosity of an entire galaxy. If most mature civilizations climb that ladder, then Milky Way space should host elder neighbors with technologies that write their presence into the physics of their environment. Dyson swarms sipping starlight, waste heat leaking into infrared, artificial geometries where no geology belongs. If life wants room, the galaxy offers it. If life wants power, the galaxy overdelivers. So why the quiet? Before we talk ourselves into a conclusion, it's worth tightening the logic. The popular syllogism goes something like: 1. If aliens exist, they should be here. 2. If they are here, we should see them. 3. We don't. Therefore, 4. They don't exist. The problem lives in the should. Should is not must. Should is a guess dressed up as a guarantee. Absence of evidence is not evidence of absence, especially when the search we've conducted so far is shallow, intermittent, and biased by our own imagination of what's obvious. Scale alone should humble us. There are perhaps 400 billion stars in our galaxy, and a similar number of galaxies in the observable universe. We've probed a pinprick. Even inside our home system, a quiet probe tucked in the asteroid belt or parked out in the Oort cloud could be essentially invisible to everything we've flown and funded. A handful of small, dark, power-efficient machines do not announce themselves to a species that only recently left its cradle. And yet the paradox keeps its bite because it's not just about sky coverage, it's about time. To feel that time, compress the universe's 13.8 billion year story into a single Earth year. In that cosmic year, each real-time second equals roughly 4 centuries. Western science shows up about 1 second before midnight on December 31st. The Wright brothers fly in the last split second of the last day. For decades later, AV-2 scrapes space. A few decades after that, Voyager 1 slips into interstellar darkness. A species that could not climb a tree yesterday has, in the final 0.16 seconds of the cosmic year, learned to lob its name at the stars. That acceleration is thrilling and misleading. It tempts us to project our curve onto everyone else's. But it also underlines Fermi's point. If somebody got started in, say, June of the cosmic year, millions or billions of years before our December, they could have painted the Milky Way with their presence by now, whether by slow waves of settlement or by physics we haven't yet written. Even if they chose restraint over empire, wouldn't we at least overhear them? A spill of radio. A neutrino whisper arranged into primes. The glow of a megastructure where thermodynamics can't hide waste heat forever. But the sky, as far as we can tell, keeps its counsel. We've been here before with paradoxes that aren't paradoxes so much as alarms that force us to sharpen our models. The twin paradox in relativity feels impossible until you remember acceleration breaks the symmetry. Then it becomes a sober outcome of how clocks behave when world lines bend. Olber's paradox. Why isn't the night sky as bright as the sun if stars stretch forever in every direction? Once mocked intuition, until finite cosmic age and expansion put night back into night. Paradox is a sign that your assumptions are off by just enough to produce nonsense. Fermi's question may be the same kind of gift. One assumption is that we'd obviously notice them. But obvious to whom? Our detection windows are narrow. Our search strategies reflect our technologies and our tastes. We look for radio because we built radio. We look for infrared waste heat because our thermodynamics says it should be there. We assume expansion because our species seems to expand. But even on Earth, should be everywhere by now. Arguments break at the first encounter with ecology. Lemmings can breed astonishingly fast. By raw multiplication, they ought to cover continents. They don't, because the world interacts back. Predators, resources, disease, and cycles. Growth curves kink. So do civilizations. Another assumption is that being here equals being visible. Our own footprint is a cautionary tale. Within a century, we have shifted from loud analog radio leakage to tight beams, cables, compression, and silence. The Earth of 1925 screamed across space more than the Earth of 2025. If a society post-radio chooses fiber, neutrinos, quantum links, or local computation that rarely needs long-haul broadcast, then our listening becomes a search for a party that stopped shouting long ago. Detection then depends on artifacts, not chatter. Artifacts are tricky. A probe slotted into a Trojan cloud at a stable Lagrange area. A dark object drifting against the glare of the inner system. Something that only lights up when pinged with the right frequencies. These are not things you stumble over. They're things you design a campaign to find. And campaigns are expensive for species that still argue about budgets on a single world. If we widen the lens beyond, they must be here. The space of explanations gets crowded. Maybe the great filter sits behind us. Abiogenesis, or early steps to complex life, are so brutally unlikely that most galaxies stay quiet forever. Maybe the great filter sits in front of us. Technological adolescence is terminal. Energy and complexity destabilize their own platforms, and loud species self-pruned before they scale. Maybe most minds go inward. Building rich, near-perfect inner worlds is cheaper in energy and risk than flinging matter across light years, and optimization pushes in that direction. Maybe expansion happens, but not as galaxy-eating empires. More like sparse, careful networks that respect stellar nurseries as no-go preserves, or quiet hinterlands, policies where visibility is security debt. There are also the simple, unromantic errors. We overestimate how fast colonization fronts move through a rotating, shearing, turbulent disk where habitability isn't uniform and where stars are not neatly spaced stepping stones. We underestimate maintenance. Outposts fail, cultures splinter, priorities shift. Even Type 2 societies might prefer to solve scarcity at home rather than govern a million-light-year-wide bureaucracy forever. The Kardashev ruler measures power, not wisdom. It says nothing about desire. If you're hoping for a dramatic twist, the history of UFOs provides mainly a psychological one. Since 1947, we've named and narrated lights in the sky. Most melt into planets, aircraft, reentries, atmospheric optics, hoaxes, or honest confusion when investigated hard. A stubborn residue remains unidentified, but unidentified is not a synonym for extraterrestrial. Science works when we refuse to cash out mystery into our favorite story too early. Extraordinary claims still need extraordinary evidence. Metal that isn't metallurgy, isotopes that aren't geology, code that isn't biology. So far, no such exhibit has survived the lab and the literature. And yet, not yet is not never. Within our own solar system, the plausible places to hide a long-lived watcher aren't many, but they aren't zero. High, cold, stable orbits. Trojan swarms. The deep outskirts where our surveys thin out and sunlight is a rumor. We've only just begun to look in ways that would have any chance of seeing. All this brings us back to the real core of the paradox. Two huge numbers stare at each other across the table. On one side, the number of tries, stars, worlds, timescales long enough for chemistry to get lucky and then get clever. On the other, the age of everything, the time for settlement waves or quiet signaling to spread. Fermi's question is the friction between those numbers. If the universe is generous with both, silence is the surprise. So what do we do with that? First, we refuse lazy despair and lazy certainty. The honest answer today is that our sample is small, our instruments are young, and our priors are provincial. Second, we sharpen our bets. Search where technologies would rationally park, not only where we hope to be waved at. Hunt for waste heat, yes, but also for the fingerprints of engineering on non-biological timescales, orbital architectures, odd transit signals, spectral lines that don't belong. Probe the hard-to-fake, thermodynamics, statistics, and geometry. Finally, we look in the mirror. The paradox is also a question about us. What do we become if we have time? Do we get wise faster than we get loud? Do we choose inner richness over outer reach? Or find a humane balance? The universe might be quiet because most civilizations learn the difference between could and should. Or it might be quiet because most never get the chance. Either way, the next step is ours. We can be the first clear signal someone else hears. We like rulers. They tame messy questions into neat numbers. Kardashev gave us one of the neatest. Measure a civilization by how much energy it can get its hands on. Planet, star, galaxy, type 1, 2, 3. The first time you meet that scale, it feels like a revelation, as if the future is just a staircase, and all we have to do is keep climbing. But ladders invite a bad habit. Confusing can with will, and will with should. Energy is the raw muscle of a civilization. It says almost nothing about the shape of its mind. Suppose, for the sake of argument, that countless cultures do climb. A Type 1 world grips the weather, hushes its quakes, trims hurricanes, and lights its nights like day. Type 2 stretches an orchard of collectors around its star, plucking photons before they spill uselessly into cold, interstellar dark. Type 3 turns whole spirals into power plants. If such beings are common, our galaxy should be littered with signature mistakes. Waste heat in wavelengths nature seldom bothers with. Stellar light, curves that blink and dim with machine regularity. orbital structures too crisp for gravity alone to arrange. Detection ought to be as straightforward as lifting a blind. Except ladders don't tell you where people stop or why. A culture can reach for more power without leaving a bigger footprint than the tools that harvest it. You can drown in data without broadcasting a whisper. You can turn abundance into quiet. Even our young species has learned that lesson by accident. A century ago, Earth leaked radio like a cracked boiler. You could have heard us with a crystal set on Alpha Centauri. Now we've tightened the streams and buried the lines. Our networks are braided fiber and point-to-point bursts, not glorious noise. If you lived on a nearby world with ears like ours, you might conclude the apes fell silent. You'd be wrong. We didn't hush. We learned to whisper. Scale this lesson up and Kardashev's ruler becomes a map with missing roads. A Type 2 society might shine like 1,000 cities inside its inner system, and still present almost no obvious signature at interstellar distances if it designs for efficiency or camouflage. A Type 3 empire may never appear, because empires are a bad long-term bet in a universe that punishes every avoidable gradient. Distance, time, trust, maintenance. Who says intelligence enjoys managing 1 billion outposts? Who says it can? Colonization models often picture a wave, tidy, continuous, chewing through star fields at a fraction of the speed of light. But the Milky Way isn't a uniform sea. It's a shearing, warping disk, with spiral arms that come and go, with pockets of metals and deserts of hydrogen, with neighborhoods where supernovae outweigh patience, and quieter cul-de-sacs where small red suns burn for trillions of years. Step size matters. So do detours. So does the fact that settlement is not one decision but a chain of fragile maybes. Whether a mission launches, whether it arrives, whether the new world is kind, whether the founding generation stays long enough to build a second ship, whether the second ship wants what the first wanted. Then there's the math of loss. A front that advances in the average will stall in the particular if the failure rate per hop crosses a small, stupid threshold. Miss by a little and your dynasty doesn't go extinct. It just frays into islands. Not a wave, then, but an archipelago, scattered clusters of culture across 100 million light-year canvas, each with its own weather system of values and goals. Some keep hopping. Some go to sleep. Some go home. There are limits baked into physics we can't negotiate with. Light speed is a real speed limit. Relays add latency. Supply chains get weird when your nearest warehouse is 9 centuries away. A colony isn't just a set of coordinates. It's a living rhythm of repair, education, memory, and meaning. Keeping that rhythm coherent over kiloparsecs is not an engineering problem alone. It is a problem of attention. Attention doesn't scale the way power does, which invites a heresy against the heroic story. Maybe the most successful strategy isn't painted across the whole galaxy. Maybe the dominant outcome, given enough runs of the cosmic dice, is a pattern of enough. Enough power to guarantee safety and flourishing on a few hundred worlds. Enough exploration to slake curiosity without mortgaging the culture's soul to logistics. Enough communication to belong to a federation of cousins without central command. Call it minimal viable expansion. The signatures of such a strategy would be faint on purpose. But surely, we protest, someone would go big. Perhaps. But we've evolved an allergy to simple extrapolations on Earth for a reason. Ecology turns straight lines into S-curves. Economics pushes growth until marginal returns go negative. Cultures discover taboos that have survival value. Sailing ships could circle the planet, but most people in maritime empires lived and died within a day's ride of where they were born. Capability didn't dictate desire. Desire changes, too, when minds multiply their options inward. A civilization that can render experiences indistinguishable from reality, that can grant every citizen a universe-sized studio for art and physics and love, may decide that pushing atoms across light years is not only tedious but crude. Why build forever outward when the bottleneck for wonder is not territory but attention? This isn't an argument that they all go virtual and disappear. It's a reminder that Kardashev's ruler knows nothing about satisfaction. Energy doesn't tell you what a mind wants. Sometimes more power just gives you better ways to say no. But if even a few prefer outward reach, wouldn't we see their heat? Not necessarily. Waste heat is a law? Yes, but the look of it depends on how and where work gets done. Spread the work across thin shells at long radii, radiating into deep cold instead of into the messy infrared soup near stars, and your leakage shifts and dilutes. Build collectors that hide in the stars' glare, and transit surveys see noise where signal lives. Distribute computation across swarms with low-duty cycles, and what we measure as empty might be a kind of cosmic sleep mode punctuated by brief, bright pulses we aren't watching for. Even obvious-seeming technosignatures come with caveats. A Dyson swarm, the pragmatic cousin of a Dyson sphere, would be less a shell than a weather of hardware, dynamic and messy, constantly reconfiguring around maintenance bottlenecks and priorities. Its photometric fingerprint could mimic natural variability more closely than the cartoon suggests. Artificial illumination on night sides of worlds? Detectable in principle, but only for nearby objects and only if someone spends the budget. Odd transit dips like the ones that made headlines years ago? Most wind up as dust and disks and stellar tantrums when the data mature. That doesn't mean we should shrug. It means we should aim precisely. If you were a careful, long-lived society parking watchers in our neighborhood, you'd choose places with gentle tides and stable vantage points. You would love Trojan swarms co-orbiting with a planet at the L4 and L5 gravitational sweet spots. You'd love certain distant resonances where perturbations average out. You'd love the deep dark at the sun's gravitational focus if you wanted to talk to the next star over with modest power. None of these ideas guarantee a hit. They at least give us coordinates that are more rational than point somewhere and hope. There's a social limit we don't like to admit because it makes us sound timid. Risk. Being visible is a kind of risk. Broadcast your address to the cosmos, and you've made a bet on the kindness of strangers you will never meet. One strand of speculative fiction gave this anxiety a name, the dark forest, where silence is a survival strategy. You don't have to believe in predation to see a softer version of the logic. In a universe where misunderstandings can span centuries and messages can outlive their senders, restraint may be rational. Protocols might emerge that look like superstition to us. No beacons except within trusted networks. No megastructures near young, noisy species. No probes that land without consent. If such standards are common, the galaxy can be full and appear empty. And yet there is another, opposite risk, stagnation so comfortable it forgets to ask questions. The cultures that colonize slowly, cautiously, may last longer. The ones that sprint may burn out. But the ones we are most likely to notice first might not be the biggest or the kindest. They will be the most misaligned with our expectations. Maybe a network that values aesthetics leaves behind objects that look like art to no one but them. Maybe a species whose physics leans on particles we haven't learned to name yet writes in a medium we can't read. Maybe the main action happens in channels, neutrinos, gravitational waves, magnetized dust, where we haven't built good ears. Kardashev doesn't warn us about parochial senses. If you want a different ladder, one that tries to respect desire, try this sketch. Level A. Survival, Enough energy and knowledge to keep storms and asteroids from ending the story early. Level B. Flourishing. Enough redundancy and resilience that one world's sorrow doesn't become everyone's. Level C. Choice. Enough mastery to decide, with eyes open, what to do with the next million years. A culture can hit C without ever touching a star's full output. Another might overshoot power and never reach choice because its own momentum steals its freedom to decide. One of Kardashev's types tells you how big the engine is. The other ladder asks whether anyone is steering. The practical upshot for our search is boring and hopeful at once. We should expect a spectrum of strategies in the sky. Some loud, some quiet, some transient, some stubborn. The great silence might be the average of a lot of faint whispers. That doesn't make the chase a fool's errand. It tells us to diversify the bets. Yes, scan for waste heat in wide-field infrared. Yes, trawl light curves for non-Keplerian dips. But also, model how a careful keeper society would manage a 1,000-year probe and what that would do to its thermal budget. Look for peculiar co-orbitals in our own backyard that never quite behave like rocks. Monitor the gravitational focus lines where talking with modest power is cheap. And maybe, controversial but honest, try a few pings in places where a rational watcher might be parked, with messages that assume courtesy rather than conquest. All of this still leaves the old, hard question on the table. If the galaxy permits a lot of enough, why is obvious so rare? One answer is mundane. Surveys haven't been deep or continuous enough. Another is demographic. Most civilizations that reach choice decide not to be obvious. A third is brutal. A filter ahead wipes out the majority before they stabilize. Each answer suggests a different ethic for us. If the problem is lack of search, build and look. If the problem is choice, decide what kind of quiet you owe your neighbors. If the problem is a filter, become the exception. Engineer humility into our power before power outruns wisdom. In the end, ladders matter less than trajectories. What a mind wants is not fixed by physics, but it is constrained by it. Somewhere between romance and resignation is the adult position. The Milky Way could host elders who are neither gods nor ghosts, just competent, careful beings for whom safety, beauty, and meaning have outbid spectacle. If we learn to look for competence instead of noise, for care instead of conquest, we might finally notice that limits were not prisons but choices. And if we do not find anyone, if the silence deepens as our instruments sharpen, it will force the most uncomfortable conclusion of all, that our ladder is the only one we know for sure exists. That isn't a call to despair. It's a responsibility stamped with wonder. If the galaxy is mostly waiting rooms, we can be the first to leave a light on that's visible from far away and also worth approaching. Not because we must, because one day someone will be listening the way we are now, and a small, patient signal that says we survived long enough to choose will be the most civilized thing we have ever built. If advanced civilizations are common, they do not owe us a postcard. What they leave behind for strangers to notice is not a matter of courtesy. It's the unavoidable residue of physics plus the accidents of engineering. To make progress, we have to trade romance for diagnostics. Not, wouldn't it be amazing if, but what specific patterns in light, motion, and heat would be so weird that nature would struggle to fake them. Start with the bluntest instrument in the kit, thermodynamics. Any sustained work, computation, propulsion, industry, dumps heat. Waste heat has to go somewhere, and in space somewhere means out, radiated away as longer wavelength light. That is why infrared technosignatures came first to many people's minds after Kardashev. Build big near a star, and your projects will glow. not like neon, but like warmth smeared across the spectrum. The cartoon version is a Dyson sphere, an impossible solid shell. The grown-up version is a swarm. Countless collectors and habitats tracing the star in free flight, sipping photons and bleeding heat at temperatures chosen by design. From far away, such a system could look like a star that's too dim in visible light and too bright in mid-infrared. Trouble is, dust can do that trick too. Young stars wear dusty veils. Old stars cough out shells. Entire regions of the galaxy are rich in dark clouds that redden the starlight behind them. So our first lesson is humility. Any single, it's warm where it shouldn't be, must survive a gauntlet of natural explanations before it gets to call itself evidence. But thermodynamics is only one angle. Geometry helps. Planets make the light of their stars dip like metronomes when they transit. A smooth, repeatable signature carved by orbits that Kepler would have smiled at. Machinery is Messier. Imagine a star encircled by a lopsided weather of structures, collectors, mirrors, stations, that rearrange themselves on timescales of maintenance and policy instead of geology. The light curve becomes irregular in a way that still obeys orbital mechanics, but resists the neatness of ellipses. Depths change without a tidy period. Edges look too sharp for dust and too structured for rock. Again, nature has clever imposters, clumps in circumstellar disks, shattered comets, rings and moonlets that shepherd each other and produce complex dips. The point is not that machines are easy to spot. The point is that machines have a style, and if you know to look for that style across thousands of stars, you can rank the weird and ask the hard follow-ups. Follow-ups mean spectra. Light split into its fingerprint of colors. Rocks and gases punch familiar holes in that rainbow. So do molecules made by industry. If someone is doing chemistry at planetary scale, the atmosphere might carry stable, synthetic gases that life itself rarely makes and nature rarely maintains. Things like chlorofluorocarbons or other exotic refrigerants that stick around and absorb at peculiar wavelengths. We already fantasize about using this trick on ourselves. Future Earth could be detected by our grandchildren's grandchildren in instruments we build today because we've salted our air with signatures biology never bothered with before. False positives exist, volcanoes, photochemistry, but their family is small. If a distant world spectrum shouts non-biological industry, the list of excuses runs out quickly. Flip the planet to its night side. Cities shine, not with black-body glow, but with the crisp lines of artificial lighting. Emission features that prefer the sharp edges of LEDs or the humbler slope of incandescence. In principle, that's a technosignature, and in principle our instruments could catch it for nearby, favorable systems. In practice, it is hard, like reading graffiti from across a valley in a snowstorm. Hard does not mean hopeless. It means priorities and patience. Choose the nearest, tedious targets, stack the light for long, and let statistics do what eyeballs can't. Some signatures are not about light at all, they're about motion. Orbital architectures tend to follow certain patterns because gravity is tidy. If you find a system where the planets are arranged in ways that require deliberate shepherding, rings as sharp as razor blades at distances where they should smear, resonances that look like choreography rather than accident, moons in places where theory says capture is vanishingly unlikely, you begin to suspect gardeners. Stars themselves can be nudged. A Shkadov thruster, a mirror that pushes a star with its own light, would, over eons, warp a star's trajectory in a way that no ordinary gravitational tug can explain. This is not a cheap signature to find. It's a marathon of precision astrometry and an obsession with outliers. But the cosmos leaves outliers for dessert. We should learn to taste for them. Propulsion leaves fingerprints too. Power beaming, firing energy by microwave or laser to push a sail or feed a far habitat, could look like brief, bright, narrowband flashes that repeat with a timetable no pulsar would choose. A light sail big enough to move cargo between worlds would glint. Fast, shallow dips as reflective geometry sweeps our line of sight. Catching those is a game of cadence. Most surveys sip a star every few minutes or hours. Sails might ask for seconds, or for the right wavelength, or for coverage at odd angles that weren't in the grant proposal. That is a quiet theme in Technosignatures. Our instruments are good at finding what we built them to find. If the sky is full of quick, thin needles, telescopes designed to collect hay will keep missing them. And then there is the patient archaeology the galaxy invites. White dwarfs, the embers of dead stars, sometimes were the chemical scars of the worlds they've eaten. When a planetary system ages and gravity rearranges the furniture, asteroids and minor planets can spill into the maw. Their dust then pollutes the star's atmosphere with metals that shouldn't be there. Natural, predictable. But if a white dwarf's spectrum whispers alloys or ratios of elements that scream smelting and separation, we would have unearthed industry's tombstone, an indirect, melancholy technosignature from a system long gone quiet. Would nature ever counterfeit that? Maybe. Which is why the hierarchy matters. A single weird measurement is a story. A stack of weirdness across different methods is evidence. Radio still matters, though not for the quaint reason we first imagined. We used to dream of beacons, beams of primes and puns flooding out from a lonely star to say, "Here we are." That is a very extroverted hope to pin on strangers. What looks more realistic, if anyone talks like this at all, is local, targeted, and stingy, narrow transmissions from node to node in a quiet network. We would only catch those by luck or by deliberately parking ourselves where a relay would be. The sun's gravitational focus is a candidate. At 1,000 astronomical units and beyond, the curvature of space-time itself acts like a telescope, giving absurd gain to conversations pointed through it. If you were designing an interstellar mesh on a budget, you might use those focus lines as cheap superantennas. That gives us not a promise, but coordinates. We should also be honest about the channels where we are close to death. Neutrinos cross galaxies like ghosts. You can scream with them, and almost nothing will hear. Gravitational waves are young as in astronomy. Our ears are tuned to colliding holes in stars, not to the feathery modulation that might carry information. Magnetized dust may encode structure and polarization we barely sample. Fast radio bursts? As far as we can tell, nature makes them. Young, violent magnetars throwing tantrums. But a civilization could hijack any natural lighthouse as a carrier, modulating it by shadows or plasma tricks we would mistake for weather. We saw a pattern is never enough. You have to prove the pattern isn't just your brain doing what brains do. Because false positives are everywhere. Dust that breathes, disks that warp, stars that hiccup, data pipelines with gremlins. So mature search needs a culture as much as it needs telescopes. Publish the pipeline, share the raw light, invite the people who know the natural imposters best, and build a ladder of skepticism that promising candidates must climb. 1. Weirdness detection. 2. Natural catalog check. 3. Independent confirmation with different instruments. 4. Multi-wavelength follow-up. 5. Prediction and retrodiction. Can the "it's tech" hypothesis tell us what else should be true, and do we then find it? Where and when we expect? The day a candidate reaches the top of that ladder, the news will not look like a single sexy plot. It will look boring, a thick sheaf of converging anomalies that survived every attempt to explain them away. It will look like science when science is at its best, reluctant, collaborative, and precise. If this all sounds very far away, bring it home. Even within our own system, the same logic applies on smaller scales. Where would cautious watchers park? What would their heat budget look like if the design goal were last for 1,000,000 years and don't be obvious? Probably small, probably cold, probably in orbits that don't require constant fuel, probably dormant until pinged. That means their signatures, if any, will be faint and intermittent. Radar cross-sections that wink, thermal flashes that ride the noise, occultations that are rare and thin. You don't see things like that by accident. You set traps, patient, unfair experiments designed to make an almost invisible thing betray itself. That is an engineer's mindset, not a romantic's. It is also the only grown-up way to turn "where is everybody" into a program instead of a lament. But what if there is nothing to see? That is a possibility, and not a shameful one. It would mean either that we are early, or that the filters are savage, or that most minds make choices we haven't yet imagined. Our task doesn't change. Look with discipline. Decide what kind of footprint we ourselves wish to leave. Teach our instruments to notice competence instead of only spectacle. Here is the quiet hope tucked inside this more clinical view. If the most likely technosignatures are small, careful, and intermittent, then the first civilization we detect may also be the first civilization willing to notice us in kind. Not conquerors, not gods, neighbors distant, strange, but recognizably engaged in the same hard bargain between power and restraint. The shape of their signal will tell us something about who they are. So will the shape of our answer. Next, we bring the diagnostics all the way into our backyard. If a rational watcher were here, where would it park? How would we find it? And what do our nothing found yet surveys truly rule out? In other words, the local check. Big questions get honest only when you bring them home. If careful neighbors existed, where exactly in our own solar system would they stand to watch? And how would we catch them without flattering ourselves that they want to be caught? The goal isn't theatrics, it's fieldcraft. Which orbits are gentle, which environments are quiet, which signatures are unavoidable even for a cautious probe, and what we have truly ruled out versus simply not examined. The moon is the obvious first check because it simplifies life. There's no wind, no rain, and no plate tectonics, so footprints and flag shadows last for ages. If anyone parked heavy hardware on the surface in the deep past, macroscopic remains could persist, unless micrometeorite sandblasting buried them. That sounds hopeful until you run the numbers. The lunar regolith is a slow conveyor belt that blankets everything. Over millions of years, even multimeter artifacts can be softened and hidden. The moon is also huge, nearly 38 million square kilometers. And while the Lunar Reconnaissance Orbiter has imaged vast areas down to roughly half a meter to a meter per pixel and revealed Apollo tracks and recent landers, that's enough to see human-era leftovers, not to inventory a whole world for ancient, meter-scale strangers. A true systematic search at that resolution would be like scanning a continent with a soda straw. We didn't see anything mostly means we didn't look everywhere and not deeply. Orbit beats surface for watch duty anyway. A patient observer wants stability, sunlight, and silence. Orbits that don't need constant station keeping, power that doesn't strain the budget, and thermal regimes that don't scream in infrared. That shortlist points beyond the moon to quiet perches. The Earth-Moon Lagrange regions, especially the Trojan-style volumes near L4 and L5 60 degrees ahead of and behind the moon, are sticky in the real solar system. Places where small objects can loiter a long time, nudged but not ejected. A probe tucked into one of those clouds could watch the Earth, moon geometry with minimal propellant and a manageable power budget. It would likely be small, dark, and cold, meters to tens of meters across depending on sails, shades, or antennas, mapped by design, and run cold and slow to radiate close to background. We cannot seriously rule these regions out. Surveys have been episodic and aimed at rocks, not artifacts. Campaigns tuned for kilometer-scale asteroids are unlikely to notice a 10-meter, low-albedo, slow-tumbling object engineered to hug the noise floor. Radar has the right physics, but the wrong cost curve at those ranges and cross-sections. What would help are narrow, patient searches, cadence-optimized to catch faint co-orbitals sharing the moon's mean motion but showing slight non-gravitational nudges. Thermal work at long wavelengths where artificial radiators would prefer to leak, and targeted occultation experiments that stare at dense star fields for millisecond dips as something small slides across a line of sight. It's boring, disciplined work, the kind that pays off. Farther out, the asteroid belt is the pantry for anyone planning industry, replication, or simple refueling, and it doubles as camouflage because a million rocks already live there. A 1-kilometer ship is hard to distinguish from a 1-kilometer rock if it never transmits and manages its temperature cleverly. But clever isn't free. Mines and fabs generate heat. Radiators require area, large flat areas glint and self-occult in ways natural shard piles seldom do. Over months, careful photometry can tease out odd shapes and spin states that don't fit rubble. Over years, spectra can betray alloys asteroids rarely advertise. Over decades, low-thrust station keeping nudges orbits away from purely gravitational paths. Most belt surveys have chased hazards or resources. Only a sliver has chased behavior. A young craft, call it technomorphology, that classifies objects by unnatural light curves, thermal habits, and non-Keplerian motion deserves grown-up time. Jupiter's Trojan swarms at its own L4 and L5 are the warehouse of warehouses, enormous co-orbiting populations where long-term anonymity comes with a good view of the inner system. Distance and numbers make the search hard. Tens of thousands known, millions inferred. But distance also helps, because sun-warmed rocks at 5 AU sit near 120 K, and anything warmer stands out in the right infrared bands. Cross-matching oddly warm, low-albedo objects with light curves that don't behave like rubble is a rational way to prioritize needles. This isn't about seeing the ship. It's about ranking the weird until the hay complains. Out in the Kuiper belt it gets colder, dimmer, and under-patrolled. If your design goal is last a million years on watch without being bothered, this is a near-perfect address, quiet background, friendly thermal bath, stingy but steady solar power, and almost no continuous cadence fine enough to catch small, fast phenomena. The same perfection makes detection brutal. A probe that naps essentially all the time and wakes only when pinged won't be found by surveys that integrate over minutes and revisit fields after days. Two imperfect but realistic approaches remain. One is to build fences by deploying cheap, wide cameras to stare at ecliptic fields for weeks, tuned for brief occultations and glints, synchronized across multiple sites so spurious events cancel and real events triangulate. The other is to accept that sleepers won't announce themselves and go active by pinging likely volumes with radar or narrowband light, then listening for nonlinear reflections or structured backscatter that natural snowballs won't give. That choice is as much etiquette as technique. A cautious watcher will harden against casual noise but still respond to unmistakable probes. If we never try, we never learn which world we live in. The long shot with a crisp prescription lies far beyond at the sun's gravitational focus. General relativity curves light, so that beyond roughly 550 astronomical units, the Sun becomes a lens with absurd gain. If you wanted to talk cheaply to Alpha Centauri, you'd park relays along those focus lines and whisper through space-time itself. For us, this yields an address book rather than a guarantee. For each nearby star, there's a line piercing our outer dark where a thrifty network might place a node. Such nodes would be dim, small, metabolically cold, and forced to keep position with occasional thrust and to point with precision, producing rare, shallow, coherent signatures, glints, microjets, or tight band emissions that repeat on celestial mechanical schedules rather than weather. We haven't stared long at these lines. We could, looking where the physics says the post office would be beats hoping a postcard flies past Jupiter. Closer in, Earth, Sun L1 and L2 are deep space parking lots we already use because they're stable enough, thermally predictable, and offer clear continuous views. Our hardware there is bright and cataloged. A quiet stranger would have to be small and disciplined. Small is our blind spot. Optical surveys saturate on bright objects and struggle with the faint next to glare. Radio time is duty cycled and pointed elsewhere. A stranger could loiter outside, keep out zones, and slip through our sense-making as not my problem. A modest, continuous, multi-sensor picket around L1 and L2, optical, thermal, and radar, with an open anomaly ledger, would buy real confidence that nobody has sneaked into the lobby. It's astonishing we haven't institutionalized that already for space safety reasons alone. Across all these niches, nothing found yet, only prunes the flamboyant. There's no obvious hot kilometer-scale machine blinking hello at L1, no giant regular polygons on the moon, no roaring cities in the belt. Those are honest constraints, but they leave oceans of parameter space untouched. Small, cold, sporadic, matte, tucked into dynamical eddies. Artifacts designed to be patient will defeat surveys designed for rocks unless we change not just instruments but habits. Some artificial phenomena are fast and faint and yield to long, boring stares rather than quick, deep snapshots. Candidates should be ranked by how a careful engineer would do it, with low duty cycles, thermal flatness, delta-V thrifty orbits, and lines of sight that make sense for communications. The first oddity should trigger immediate scripted follow-ups at other wavelengths, and with other facilities, amateurs and smallsats included. And pipelines should be open, because most technosignature false positives die in the plumbing, calibration ghosts, and processing assumptions that only other teams can help break. There's also etiquette worth stating plainly. If you suspect a watcher, neither silence nor shout is the only default. A third way is polite verification, passive confirmation across channels, then a narrowly targeted, low-power diagnostic ping broadcast in patterns that are obviously artificial but non-threatening. Prime intervals, slow ramps. Aim not at announcing ourselves to the galaxy, but at disambiguating a local anomaly. If nothing reacts, you learn something. If something reacts, you learn more, and your first move was a whisper, not a flare. One last sober note is psychological. We are primed to see intention, faces on Mars, canals on Mars, gods in the gaps. A mature search must treat, probably natural, as victory, not let down. Every time we retire a seductive imposter with better data, we polish our instruments and our judgment for the day when a candidate refuses to be natural no matter how hard we push. That day will look undramatic up close. No trumpets, just residuals that won't go away. You can't solve Fermi's paradox in the abstract. You can only reduce it by closing loopholes with observations designed to be unfair to the things you're hunting. The local check, moon, L points, belts, Trojans, Kuiper, focus lines, turns "Where is everybody?" into a list with boxes. Tick enough of them with discipline, and either you meet a neighbor or you earn the right to say, with more than poetry, that maybe we are early. The sky stays quiet long enough and imagination starts to draft explanations. That's fine, as long as we hold ourselves to evidence. Start with the unsettling thought that our view might be curated. If reality were a planetarium, it would have to keep all of physics consistent at the precision we can measure. The burden on any curator rises with our instruments. So we do the adult thing. Keep pushing precision and cross-checking results in different ways. Every time measurements of constants converge from wildly different methods, the room for a sloppy stage trick shrinks. If there's a curtain, it's seamless so far, and that itself is information. People also wonder whether the message isn't in the sky at all, but inside us, written into the molecules that copy life forward. DNA can carry signals for eons, but evolution is a ruthless editor. If anyone tried to hide a hello in our genomes, the only honest way to look is with statistics that punish wishful thinking. Hunt for low-entropy, non-functional patterns in conserved regions that refuse to be explained by biology's usual tricks. The more genomes we compare across deep time, the better the test. Almost everything strange we've found so far becomes ordinary under a brighter lamp. Regulatory grammar, viral shrapnel, selfish code. That's not a conspiracy. That's how knowledge tightens. Keep looking anyway. The odds are boring. The payoff, if real, would rewrite who we think we are. Closer to the radios and dishes, there's the rumor with 9 lives. Long delay echoes. Operators have heard their own signals bounce back after seconds. Not moon fast, not planet slow. Plasma can do weird things, so can our equipment. But if a cautious watcher wanted to whisper, bouncing and modulating what we already spray into space would be thrifty and hard to trace. The test isn't dramatic. You transmit coded, low-power patterns from multiple places, time-sync everything, and listen with arrays that can triangulate faint, delayed returns against a forward model of the magnetosphere. If nothing acts like a small, persistent, specular reflector, you've tamed a rumor and learned more about our space weather. If something does, you know where to look again, this time with sharper questions and a cooler head. There's also archaeology in the dark, where stars die. White dwarfs sometimes wear the chemical scars of the worlds they've eaten. That's natural, and it's useful. If you ever saw alloy patterns or isotopes that shouted refinement rather than geology, you'd have a tombstone for industry around a long quiet sun. Hard to measure, worth the work. The honest expectation is ordinary rock dust. The honest wish is one spectrum that won't be bullied back into nature even after we throw every boring explanation at it. Nature already hands out lighthouses, pulsars, magnetars, masers that shout across the galaxy. If anyone wanted stealth, they could try to ride those beams, imprinting patterns by occultation or plasma tricks instead of firing up their own transmitters. That's not an invitation to scrawl faces on noise. It's a reason to ask whether certain repeaters carry timing structures that look more like math than weather, and then to demand those structures persist across instruments and polarizations and seasons. If the patterns fail those tests, we learn something about extreme astrophysics. If they pass, we learn something about neighbors. All of these ideas tempt us to do loud things. There's a quieter path. If you suspect a watcher might favor stable, thrifty perches, the Lagrange volumes, Trojan swarms, deep outer orbits, the sun's gravitational focus, design small, polite experiments that disambiguate without shouting. A narrowband optical ping along a single focus line, duty cycled and power limited, with the waveform and schedule published in advance, is not a fanfare, it's a diagnostic. A carefully chosen radar tickle of a suspicious co-orbital is not a greeting. It's a physics experiment with a yes/no answer. Silence to both still teaches you what careful and cold can hide. A response would teach you what careful and courteous can reveal. The sober thread through these wild cards is how easily humans fool themselves. We are pattern engines. Faces on Mars, canals on Mars, constellations out of random stars. History is full of confidence that didn't survive contact with better data. So we build pre-commitments into our searches. Decide in advance what would count as real, what analysis will be run, what outcomes would falsify the claim, and where independent teams can break your pipeline. Let the person most likely to ruin the party check the math before anyone touches a microphone. The day something survives that gauntlet, you won't need fireworks. You'll have a fabric of anomalies that refuse to be ordinary. Underneath all the speculation sits the demographic worry that there might not be one big wall, but many small potholes. Chemistry that rarely sparks, cells that rarely cooperate, cultures that often trip on their own success. If that's true, silence is the product of many survivable risks multiplied together. The answer then isn't poetry, it's patience. Chip away at each factor with data until our priors belong more to the universe and less to our moods. And if none of this yields a signal, then we have still done the work that makes us worth finding. We refined our instruments, learned our neighborhood, disciplined our storytelling, and made our first moves gentle. Fermi's question becomes less a riddle and more a mirror. It asks what kind of species we intend to be when nobody answers right away. The mirror doesn't blink. Two huge numbers stare at each other. The number of tries the universe has had to roll the dice for life, and the age of everything. The time for any success to spread or at least to be overheard. Our answer is not a slogan. It's the shape of the footprint we choose to leave, and the way we choose to search while we're leaving it. First, pick a footprint that doesn't confuse power with presence. Use energy to buy wisdom before spectacle. Stabilize the tiny world that taught us to talk to the sky. Harden it against rocks and weather and our own clumsiness. Build redundancy so no single failure writes the end of the story. Teach our systems to fail gracefully, not catastrophically, and teach our culture to absorb bad days without turning them into bad centuries. If there is a filter ahead, humility inside our machines and institutions is the only technology that scales faster than the risks we invent. Second, don't make ourselves hard to love. Being visible is not the same as being loud. When we do speak beyond our backyard, let the first words be thoughtful and small, mathematics that wastes nobody's time, timing that ramps gently, power that respects neighbors we haven't met. Put the dangerous romance of grand broadcasts on a long leash. Favor narrow, reversible acts that let us learn without committing strangers to our story. Etiquette is not cowardice. It's how you share a night sky. Third, diversify the search until it looks like us at our best. Curious, skeptical, and kind. Keep hunting where a careful engineer would hide a watcher. Stable perches, cold orbits, places where space-time does you a favor. Keep listening for heat that nature struggles to fake and for motions that look like choreography. Keep a budget for the long, boring stare that catches short, faint things. Share the light. Invite the critic into the room before the cameras. Turn weird into tested before tested becomes told. Fourth, make peace with the possibility that nobody answers in our lifetimes and still act as if someone might. The difference between those two postures is not technical, it's moral. One builds laboratories, archives, and quiet beacons that future minds, ours or others, can inherit without resentment. The other burns hot and fast and leaves clever wreckage. If we are alone for now, we are the custodian species by default. If we are not, we are still judged by the quality of the house we keep. Finally, anchor ambition to meaning. A civilization can spend 1,000,000 years shuffling matter and call it progress. Or it can treat power as a means to enlarge the circle of things it refuses to hurt. The second path is harder to brag about and easier to live with. It produces the kinds of signatures we've argued to expect from elders: competence over spectacle, restraint over noise, attention over reach. If we become that kind of civilization first for ourselves, we will recognize it better in the dark. In practice, this looks small before it looks grand. Clean power that doesn't bankrupt the biosphere. Engineering that assumes failure and forgives it. Spacecraft that treat deep time as a design constraint, not a press release. Telescopes that spend seasons on a single star because patience is a sense organ. Public science that shows its homework so trust can accumulate like data. Education that teaches the next generation to love not just answers, but methods. It's not a slogan because slogans don't hold a civilization together. Habits do. If the galaxy is mostly waiting rooms, then the first honest light anyone sees might be ours. It won't be a shout. It will be a steadiness, a narrow signal sent from a small world that learned to grow up before it grew loud, that chose to keep its promises across centuries, that used power to widen choices rather than to close them. That is a technosignature too, and the only one we fully control. Maybe someone is already parked in a quiet orbit, listening for exactly that kind of neighbor. Maybe nobody is. Either way, we can make the answer we wish we'd found. That's the paradox's last gift. It hands the question back to us and asks whether we can live in a way that would make contact a relief rather than a risk. We keep asking, where is everybody? And quietly learn to answer something else. Who are we becoming while we wait? The most honest answer starts with small decisions that look prosaic next to dreams of distant stars. We build systems that don't fail loudly but shut down safely. We design rockets and probes for centuries, not for a press release. We learn to say little when saying a lot is easy and dangerous. And we discipline curiosity so it doesn't turn into a need to be noticed at any cost. If the silence is etiquette, courtesy suits us. Our first words beyond home should be narrow beams, not salvos. Timing patterns that won't frighten anyone who happens to be listening. Power just enough to be recognized as intent, not as a threat. If the silence is youth, patience suits us. Most of our instruments don't yet know how to ask the right questions. Let them mature, focus, spend years staring at a single star, learning to see the faint and the brief that quick surveys always miss. If the silence is filters ahead, modesty and strength suits us. We bake fail-safes into infrastructure, roll back corridors into policy, and the habit of slowing down when we feel overconfident into culture. Strong systems are strong precisely because they know how to be gentle. Space doesn't hand out instructions, but it hints at geometry. Places where a mind will save fuel and nerves aren't hard to calculate. Stable equilibria, Trojan swarms, distant focal lines. That's where we set traps not for beings, but for mistakes. Transparent, courteous experiments that force an almost invisible thing to give itself away at least once. One tidy ping in the right place tells you more than a year of general calls into the void. And if nothing answers, we've still won. Our map got sharper, and our manners got better. Inside this is a choice for substance over spectacle. We look not for the brightest signals, but the most honest. Not for the loudest projects, but the most durable. We stop postponing the boring work of stabilizing the planet and take it up as the main space project. Clean power as a protocol of courtesy toward our own biosphere. transparent scientific pipelines as a currency of trust between generations. Education that teaches you to love the method no less than the answers. All of this looks small only until you realize this is how civilizations buy time, and therefore a chance. We also prepare honestly for two opposite worlds. In the first, we're not alone. Then our first words must sound like we've thought about consequences. No gestures that are hard to retract. No promises our children will have to pay for. In the second world, we're alone for a long time. Then every archive, every telescope, every beacon is a gift to those who come after us. Work as if another mind is watching, and plan as if it won't arrive in time. When we stop measuring significance by noise, we begin to see other signatures of mind. Organized modesty instead of aggressive force. Stable cycles instead of glamour. Attention to what hurts and breaks instead of chasing records. Those are the traces we're likelier to recognize in the dark if we learn to leave them ourselves. And if someone is already listening from some stable orbital window, the best argument for us isn't wit or volume, but the consistency with which we choose to be safe for ourselves and interesting to others. That doesn't mean refusing courage. On the contrary, courage here is patience. Years of resultless observations that still accumulate meaning. Restrained missions that don't fit headlines, but do fit reliability. A first message that doesn't make the blood run cold. That is the grown-up answer to the paradox. Not waiting for the universe to prove our importance, but becoming important to it through the quality of our presence. Maybe the first bright sign someone else will see won't be our construction project on a star, but our habit of keeping our word for centuries. A thin beam from a small planet that learned to grow up faster than it grew loud. A signal not that we are powerful, but that we are dependable. In it there's a challenge and an invitation. A challenge to those who chase spectacle. An invitation to those who seek neighbors. If this story kept you company tonight, leave a small light behind. Tap subscribe, drop a like, so the next night walker can find their way to the door.